then you integrate. Just follow these steps and you will do great. First you separate and then you integrate. Just follow these steps and you will do great. First you separate and then you integrate. Just follow these steps and you will do great.
Tis the season to be serving.
When I was solving equations, I was feeling amazing.
Greetings. So there are a lot of non-calculus things that calculus students struggle with. The main one is probably algebra, but another big one is also trig. So today I want to show you some easy tricks to be able to maneuver the unit circle trig that you're going to find in calculus. Now, the very first thing you have to do, you're going to have to memorize the sine, cosine, and tangent of pi over 6, pi over 4, and pi over 3. There are conceptual ways to figure that out, of course. Thinking about the 30, 60, 90 triangle or the right isosceles triangle. So these things can be figured out conceptually, but we recommend just memorizing, studying and memorizing and knowing like the back of your hand the sine, cosine, and tangent of pi over 6, pi over 4, and pi over 3. So study that first. And that will get you through most of the trig values that you're going to encounter in calculus. So a lot of them are just going to be those three angles. Of course, you have your quadrantal angles. And the quadrantal angles, we really don't stress memorizing those, but thinking about the coordinate plane and where they lie and allocating cosine with x and sine with y and understanding it's a unit circle. And so those points on the end are a distance of 1 from the center. So that's kind of how we recommend those quadrantal angles like 0, pi over 2, pi, 3 pi over 2, and multiples thereof. But here we're mainly concerned with the three angles, pi over 6, pi over 4, and pi over 3. Now, again, you're going to have those memorized. So if someone asks you, what's the cosine of pi over 3? You're going to easily know 1/2. They ask you what's the tangent of pi over 4? You can easily know it's 1. They're going to ask you what's the sine of pi over 3? You're going to easily know it's the square root of 3 over 2. So those things you're going to have memorized. And that's going to get you through a lot of problems that you're going to encounter. Now, it's going to get tricky when they give you something like an angle 7 pi over 4 or 5 pi over 6. Or 11 pi over 3. Those sometimes get tricky. However, a very easy trick to remember, as we know these angles I just rattled off, angles greater than 90 degrees, so angles that are in quadrants 2, 3, and 4, and sometimes it could be in quadrant 1, but over 1 revolution. The deal is their reference angle is very easy to determine. For instance, the reference angle of 7 pi over 4 is pi over 4. The reference angle of 13 pi over 6 is pi over 6. The reference angle of 25 pi over 3 is pi over 3. So any angle that's over 3, its reference angle is pi over 3. Any angle that's over 6, its reference angle is pi over 6. Any angle that's over 4, its reference angle is pi over 4. So the reference angle means, of course, for instance, if I'm doing sine of 7 pi over 4, that means that numerically, the sine of 7 pi over 4 is the same as the sine of pi over 4, which is the square root of 2 over 2. That's the numerical value. Now, I still need to determine if that number is going to be positive or negative. But I can very easily determine its reference angle if it has a denominator of 4, 3, or 6, which are the angles that you're going to see that, of course, you can do like this are going to have. Now, how do I make the determination whether the angle is positive or negative? So the example I'm using right now is 7 pi over 4. And I know the number is going to be the square root of 2 over 2. But the question is it going to be negative square root of 2 over 2 or positive square root of 2 over 2? So generally how we normally find this is we think about what quadrant the angle lies. And we understand that sine correlates to the coordinate plane with y. And y would be positive, y is positive in the upper quadrants. That would be quadrants 1 and 2. And it's negative in the lower quadrants. Those would be quadrants 3 and 4. So sine of theta is positive in quadrants 1 and 2 and negative in quadrants 3 and 4. So we can take that angle 7 pi over 4 and see what quadrant it lies in. Now, what's the easiest way to determine what quadrant an angle is in? Because 7 pi over 4 may be somewhat of a strange angle. Just understand that the pi over 4 part is 45. And so it may be easier for you to think of the angle in degrees. So remember, the pi over 4 part is 45. And if you were doing something like 11 pi over 3, remember the pi over 3 part is 60. If you're doing something like 15 pi over 6, well, not 15 pi over 6, 11 pi over 6, remember the pi over 6 part is 30. So back to 7 pi over 4. I know the pi over 4 part is 45. So all I have to do is multiply 7 times 45, which is 315. 315 happens to be in quadrant 4. And again, you think about the conceptual deal. Sine is y. Y is negative in the lower 2 quadrants, and quadrant 4 is one of those lower 2 quadrants. So that means that the sine of 7 pi over 4 is going to be negative, meaning it's going to be negative square root of 2 over 2. Now that's one way to determine the sine. There was a little thinking there. You're thinking about quadrants, and you're thinking about, cosine is affiliated with x, and so it's positive in the quadrants on the right, which are 1 and 4, and negative on the quadrants on the left, which are 2 and 3. Sine, of course, is positive on the top, 1 and 2, and negative on the bottom, 3 and 4. And tangent, of course, is positive wherever sine and cosine have the same signs. So tangent is positive in quadrant 1, where sine and cosine are both positive, and also in quadrant 3, where sine and cosine are both negative. And tangent, of course, is negative in quadrants 2 and 4 when sine and cosine have opposite sides. So that's the conceptual way of thinking about it. But there's also an easier way to determine. You still have to figure out what quadrant the angle is in, but there's an easier way of figuring out what the sine of the particular trig value is based off the quadrant. And it's based off a very simple axiom that we should all know and love. All students take calculus. So all students take calculus. I'm putting A for all in quadrant 1. I'm putting S for students in quadrant 2. I'm putting T for take in quadrant 3. And I'm putting C for calculus in quadrant 4. Now, what does that mean? All students take calculus is a very optimistic sentence. Not just optimistic because it's something we should aspire for all students to take calculus, but also optimistic because it's telling me what trig values are positive in what quadrant. So let's go back. Quadrant 1, all the trig values are positive in quadrant 1. So when I say the trig values, I'm speaking of the main three. I'm speaking of sine, cosine, and tangent, of course. So sine, cosine, and tangent are all positive in quadrant 1. In quadrant 2, students, S, only sine is positive in quadrant 2. Cosine and tangent are negative. So the S tells you what's positive. Only sine is positive in quadrant 3. In quadrant 2. In quadrant 3, take, T, only tangent is positive in quadrant 3. Sine and cosine are both negative in quadrant 3. Only tangent is positive in quadrant 3. And calculus C4, only cosine is positive in quadrant 4. All students take calculus tells you what trig values are positive in each quadrant. And of course, if you're not one of the ones that are positive, then of course you must be negative. So hopefully those little tricks will help you out with the unicircle trig you're going to encounter on your calculus problems, and we'll see you next time.
Specialize in science and math, original black men, busting thoughts that pierce your mental, the fierce, ripping your section. Vocal toe to toe, impeccable, splitting your back, son. Simple as addition and subtraction, black thought, the infinite relax one.